Hello everyone. In this video, I'm going to be talking about compound interest, but now we're going to be looking at compound interest that is calculated more than one time per year. So the first thing we have to do is we actually have to adjust our compound interest formula. So let's start with that. So if you remember the formula for compound interest, the future value is equal to the initial investment, the principal, times 1 plus the rate, and then this is raised to the t power. That's for when our interest is compounded once per year, meaning the interest is calculated one time a year. So now I want to adjust this for when our interest is calculated more than one time a year. Now there's two adjustments we need to make. And to do that, we're going to have to introduce another variable. So we're going to introduce the variable n. And n is going to represent the number of times our interest is compounded per year. So, for example, if my interest is compounded monthly, n would be 12 since there are 12 months in a year. If my interest is compounded daily, I would use 365. If my interest was compounded quarterly, n would be 4 since there are 4 quarters in a year. So the adjustments I need to make, so our future value is going to be equal to our principal times 1 plus. And now the first adjustment we're going to make is our interest rate is actually the interest rate for the entire year. So if I'm splitting that up among different compounding periods, I need to take my rate and I need to divide that by n. So that takes my interest rate for the entire year and it splits it up amongst how many times I'm going to compound my interest. And then the second adjustment we need to make is to our time. So t represents the number of times that we compound since it's only compounded once per year. But now we're compounding multiple times a year, so I need to multiply t times n. So for example, if I'm compounding monthly and I'm keeping my investment in the account for 5 years, that's 12 compounds for 5 years. That gives me a total of 60 times that I'm going to compound my interest, and that's what this exponent represents. So that's how we adjust our formula so we can take into account multiple compounds a year. All right, now let's use this in an example. So it says you deposit $7,500 in a savings account that has a rate of 6% and the interest is compounded monthly. So right away, compounded monthly, that tells me I need to use this formula and n is going to be equal to 12. How much money will you have after 5 years? And then let's find just the interest after 5 years. So I'll write down our formula again. Our future value is equal to the principal times 1 plus r over n raised to the nt power. All right, so first our future value, this is going to be equal to our principal, which is $7,500. And then we'll multiply by 1 plus our rate as a decimal, so 0.06, divided by the number of times we're compounding per year, so compounding monthly, so n is 12. And then we'll raise this to the n times t power, so 12 times the number of years, which is 5. Now what I like to do is a little bit of simplifying before I type this into my calculator. So 7,500 plus, and then here 0.06 divided by 12, that is the same as 0.005. And then the multiplication in my exponent, 12 times 5, we get 60. And again, what this 60 represents is I'm compounding my interest a total of 60 times over the course of 5 years. So we're going to end up with 7,500 times 1.005 to the 60th power. And now when we type this in and when we calculate this, we need to make sure we follow our order of operations. So I'm going to do 1.005 to the 60th power first, and then I'm going to multiply it by 7,500. And if I type this in, what I end up with for my future value, I get $10,116 and about 38 cents. So I'm rounding to 2 decimal spots to represent the number of cents. So that takes care of letter A. And then for letter B, to find our interest, what we need to do is we're going to take our future value and we're going to subtract our initial investment, the principal. So we're going to take the $10,116.38 and let's subtract away our initial investment of $7,500. So what we end up with then is $2,616.38. So that's how we use the formula to find the interest when we are compounding more than one time a year.